Chapter 6, Study Guide. Given the relation described, identify if this relation is a function or not a function, and then you're going to describe why. First of all, to be a function, every input has to have exactly one output. One way to look at this is to just look at all the inputs. And if they are all different, then it would be a function. Here we have 0 repeating twice, so this is not a function. I also want to show you that you can use a graph to see if it's a function. So the ordered pair 0, 1 over 0 up 1 would be here, and 0, 2 would be here. 1, 3 is here, and 2, 4 is here. Then we can think about the vertical line test. And we can use the vertical line to determine if it's a function. And you can see right here, the ordered pair, the input of 0 has 2 outputs. So it does not pass the vertical line test. It's okay here and here, but this right here, when it hits twice on the vertical line, that makes it not a function. Here's the description you should say. This is not a function because the input of 0 has 2 outputs. Let's look at the next one. Okay, here's another relation. Let's look to see if this is a function. Okay, one way again, we're looking at all the inputs. If they're all different, then it is a function. So in this case, 0, 1, 2, and 3, these are all different. So this would be a yes, this is a function. And we'll have to describe why. But let's also show it on the graph, and then we'll do the vertical line test. So our first ordered pair, 0, negative 1, would fall on the y-axis. 1, negative 2, 2, negative 3, and 3, negative 4. And now let's do the vertical line test. Okay, so as I move my line across the graph, to pass the test, only one point can hit the line at a time. Yep, so this passes the test because every input has exactly one output. So let's write our reason why. Okay, so something like this. This is a function because every input has exactly one output. Okay, similar question, but now it's a mapping diagram. Is this a function? So we have to, again, examine those inputs to see if every input has exactly one output. So, it looks like 3 here, something's going on with 3 right here. Looks like 3 is paired up with 2 different things. Let's see it on the graph so we can try that vertical line test. Okay, so 2 pairs with 7, so over 2 up 7. And 3 pairs with 1. And 3 also pairs with 7. Right there. And then 8 pairs with 11. Okay, so here we go. It passes here, but nope, it hits there. It hits the line twice, so it does not pass the vertical line test right here. So this is not a function. Okay, so I'm checking not a function, and then my explanation could be something like this. It's not a function because the input of 3 has 2 outputs. Okay, now we're looking at the graph and deciding if this is a function. So when I see a graph, I like to do that vertical line test. All right, here we go. Let's see. 1 hits once, hits once, hits once, hits once. So it looks like it does pass the vertical line test. Even though it's a curve, it's nonlinear, it still is a function. Why is it a function? We could say it passes the test. We could say every input has one output. So something like that. This is a function because it passes the vertical line test, or every input has exactly one output. For 5 and 6, there are 2 parts here, so hopefully you notice that. Tell whether each function is linear or nonlinear, and then tell whether it's increasing or decreasing. So we have to do both parts. The first one is a situation where a container contains 8 gallons of water. Water is then added to the container at a constant rate of 0.2 gallons per minute. So if I thought of this as an equation, y equals mx plus b, we would say y equals, we need the rate, x, plus the initial value. So it starts off with 8 gallons of water. So is this linear or nonlinear? This does create a totally normal equation in y equals mx plus b form. So this is linear. If I graphed it, it would be a straight line. And is the container, is it increasing or decreasing? The water is being added, so the water level would be increasing. The second one, we have input of time and the output of temperature. So after 1 minute, the temperature is -1 degrees. After 2 minutes, it's -2 degrees, and so on. So is this linear or nonlinear? First, I would look to see if there's a consistent or a constant rate of change. So like in the y's, it looks like it's dropping down 1 each time. In the x's, it looks like it's increasing 1 each time. So that's consistent. If it's consistent, then we say it's linear. Is it increasing or decreasing? Well, the temperature continues to drop, so we would say decreasing. Sorry, it's a little sloppy. I also want to take a moment to write the equation. So the rate of change is, it's dropping -1, the change in y over the change in x. So it's dropping 1, and the change in y value is over 1. So our rate of change is -1. And then if we were to try to get the 0 term, the initial value, this would start out at 0. So my equation would be right there.